Hello and welcome to Tech and Tutorials. In this video, I'm going to explain the KinematicBody2D, so you'll be able to use it for your specific needs too. Alright, actually this is a tutorial here in the documentation of Godot. You can find it, and I will also put the link of this in the description. So let's get started. Okay, first of all, we need to understand this fixed process. Okay, to manage the logic of kinematic body or character, it is always advised to use fixed process, which is called the same amount of times per second always, which means that makes physics and motion calculation work in a more predictable way than using the regular process. Okay, and what does it mean actually? It means that the fixed process function is called approx 10 times more than the regular process function. You can consider it that fixed process function called every 100 microseconds and the process function called every 100 milliseconds. Something like that. Okay, to set up the scene, we need something to test, right? We need something to test. So to set up the scene, we need to download the scene from the tilemap tutorial, and I will also put the link of this in the description so you can check there. Okay, I have already downloaded it. Okay, so let me import this scene and the project. So browse, and I have put it on my desktop, so I'm moving to desktop. Okay, and here is the project. Open. Sorry. Okay, open, import, and here is the scene. Alright. Okay, to set up the scene, first we need to set the character. Okay, so KinematicBody2D, let's add the node of KinematicBody2D. KinematicBody2D. Okay, and then we need to add a sprite for the character. So we'll add a sprite by searching and typing sprite create. Alright, let me drag the character. Here we have our character. Okay, now we need to add a collision shape 2D to check for the collisions. Okay, I'll explain step by step. Let me add the collision. Okay, so collision shape 2D. Here we have it. Create. Okay, now we need to choose the shape for the character. So let's add the shape, and we choose new circle shape 2D. And okay, let me zoom. Okay, we need to make it bigger, so let's edit the shape, add it. Okay, now we will increase the radius to approx 30. Alright, now let me okay, it's fine, it doesn't matter. Alright, now let me add the script to our KinematicBody2D. Okay, let me call it player.gd. Okay, let's create. Okay, now let's save the scene. Command S. If you're on Windows, you can say Control S. So I'm just saving the scene as it is. You can change the name if you want. Alright, so here we have set up the scene, all this. Okay, now we need to create an instance of our character in the tile map, in the map scene. Okay, so let me move to map scene. I've just opened the map scene here. Okay, Now let me create an instance for the, you can create instance of another scene if you want from this button if you don't know. So I'm just creating an instance of the character, and let me drag the character here. Alright, cool. Here is our character. So let's move to the dock. Alright, here we have the kinematic body. Okay, kinematic body will do nothing by default. It has a really useful function called move. Okay, this function takes the vector2 as an argument. Vector2 is a type which has x and y coordinates, alright, and tries to apply that motion to the kinematic body. So what it does, it takes the parameter x and y in the vector2 and move the kinematic body 2D according to that vectors x and y coordinates, x and y. If we increase the x, it will go horizontally, it will move horizontally, or if we add the value negative or positive, whatever, to the y coordinate, it will move vertically up or down. Alright, if a collision happens, it stops right at the moment of the collision. So if the collision happens whenever it collide with any other object, let's say floor, so it will stop immediately at the right of the moment of the collision. Okay, so let's try this script. Okay, and I'll explain you after pasting it. Okay, so let's move to this script and let's just paste it all and replace it with the code, and let's say save, and let's try running the code. As you can see that it is falling. What we have done, okay, we have done, as I already mentioned, that it moves the character kinematic body 2D, okay, and vector2 is an argument which it takes, and 0 is x and 1 is y. So it is when the fixed process called, as I already mentioned that multiple times. So when it was called and it is moving the character in that time, so moving it 1 means down, y, every microsecond it is moving one pixel. Okay, 1 pixel for physics frame. Alright, so what is next here? Okay, let the actual game begins. Okay, we need to add some gravity. Okay, and let's create some motion with this code. So let me apply this code and replace with this code. Okay, if I'm going too fast, then you can pause the video and try to understand, or rewind or playback to understand. Okay, so here we have a constant variable by the keyword const, C-O-N-S-T, and we have named it gravity, which is 200, float. Okay, float is a type. Okay, in GD script we don't need to care about types this much because it is okay, just leave it for now. Okay, the variable velocity, we have created the variable velocity of type vector2 because we need the vector2 to move the character, to move the kinematic body. Okay, so we are adding velocity, which is vector2, and it is and now we are adding to the y coordinate delta multiplied by gravity, which is 200, and delta is something, a little amount of value, something like 0.01 and so on, very little. So it is multiplied by gravity and then added to the y of this velocity vector2. Then we are creating a motion variable by calling the keyword var and motion, which is the name of, we have just, okay, Motion is equals to velocity multiplied by delta. Now again we are multiplying the velocity, the actual velocity, to the delta, means x, y both. Alright, so it will create the motion, and then we are moving it with the function move motion, and motion is actually the vector 2. Alright, just multiplied via the delta, and it is also the vector 2. So now let's check what we have done and what are the changes here after adding the gravity. Now the character falls smoothly, better than before, right? Because the gravity this time was really high. Last time it was only 1 and now it is 200. It was moving pixel per frame, per physics frame. Okay, let's move. Now the character falls smoothly, as I said. Now let's move the character to the left and right. Okay, let me paste this code and replace with the existing code. Alright, now let me explain what we have just added. We have added the walk speed after the gravity, and walk speed is 200, which is constant also. And then again we have used the conditional statements, if, else. We have used else if actually, but it is short in GD script LF. Okay, so we are using the input class to use the input to take the input. So if the action pressed UI left means the left arrow key, we will do this, and the right arrow key we will do this, else we will do this, means if this will only run this thing, this is statement, or this is statement, or this is statement, only one statement will be running. Okay, so velocity dot x means it now we are calling the x coordinate and telling to move in horizontally. Okay, minus walk speed means negative to the left. Okay, and positive value means to the right. This is minus and this is plus, positive, negative, positive. Okay, so we are just adding it. Actually, we say when the key is pressed, velocity.x will be this, velocity.x will be this if we press right. If nothing is pressed, then the velocity.x will be 0. And then again we are doing the same. We're just multiplying that velocity with the delta, the little amount of time, delta time, and then we are adding it to the motion, and then we are adding that motion to the move function to move the kinematic body. Okay, let's try to play this. Okay, what is happening? We're not actually moving. Let me retry. Hello, let's retry. Oh man, it is moving, but when it hits, it stops. Alright, as it is already mentioned about the move function, that if a collision happens, it stops right at the moment of the collision. And why it is happening? Alright, why it is happening? There's a problem. It doesn't work very well. So according to this diagram, we can understand what is actually happening. The current position is something like here, and it stops here when we press the right key, and it stops. Alright, at the moment it stops right at the moment. It actually moved to some more, it actually complete the distance little more, something like here, right? Something like this, the desired position in the scene. It moves like this and then it stops. It should move to the right or something similar, right? So what is happening actually? Let's see. The solution. Okay, we need the solution. This situation is solved by sliding by the collision normal. KinematicBody2D provides two useful functions. One is colliding, and the second one is get collision normal. Alright. Is colliding is to check if it is colliding with any other object or any other collision 2D object. Okay. And get collision normal. So what is actually normal? Alright, if you don't know, let me explain what is normal. Normal is something like the counteracting force. Let's say if the character is standing on the floor and gravity is pulling it, then it should be get into the floor, right? But it won't, because there is a force which is called a normal force, which takes the character on the floor and not get into the floor, and that force is called normal force, and we're actually referring to that normal. So with get collision normal, we get the normal, that normal. Okay, it is something physics. If you know about the physics and know about it, you can easily understand. If not, then wait. Okay, and bear it with me. All right, so current position is this now, and when we call it the get normal, we will be sliding using this function. Okay, let me move to the next step and I'll explain it with the code what actually happening. So let me just copy it and paste it in the script. It will be more sensible after getting it and watching it. Okay, let's try it. If it works. Yep, it's working. Okay, great. Now what happened now? Okay, stop right there. Okay, now let me explain the code. What is new here? So what we have done here, we're checking if the character is colliding. Okay, this will return true if the character is colliding with the floor or the wall or any other collision 2D, collision shape 2D. Okay, then we are getting the collision normal. Collision normal is something like of type vector 2. It represents the it will get that x and y coordinates at that position. Okay, actually the normal of x and y. I'll let you know more in detail later. Okay, so we're getting that normal force as I explain what is normal. Okay, it is getting that normal, and after this function we have a slide function. We are storing that normal force in the n variable, and then with that normal force we're calling a slide function provided by the Godot. We are moving that normal to slide. Okay, and then as I mentioned already, that move function moves only let me use the document. Okay, when colliding, the function move returns the remainder of the motion vector. Okay, I was a little okay. When colliding, the function move returns the remainder of the motion vector. That means if the motion vector is 40 pixels but collision happened at 10 pixels, the same vector but 30 pixels long is returned. Okay, it is saying that a move function will move only how much it actually can move, and then returns the rest of the motion to the variable if we are saving it to any variable, just like in the motion. Okay, so let's say if it needs to move to 40 pixels but collision happen at 10 pixels, then the 30 pixels will be returned. Okay, so what we're doing is we are getting the motion from the move function in the motion variable, and here we are providing that motion to that slide function, so it will move according to our predictions, right? Okay, so we are also telling that move to this velocity and also providing the motion. Okay, alright, so when we move, it will move according to our predictions. Alright, I think that's it for this. If you have any questions regarding this and you think if I'm going too fast, then please let me know. And if you have any problem, any questions, then let me know in the comments below. And thanks for watching. This is it for now.